for those two, that's not the right one. For number 2, what answer did we get? It would probably be easier if you left fractions as improper fractions instead of mixed fractions. Not that that's wrong, it's that you won't see mixed fractions on any of my stuff or you won't see them. Two to half or 5 halves, yes. And then.
Originally, yeah, I just forgot to shoot the table. So
Yeah. Here, let's say I combine our terms, we have 5 and 6, that would give us 11. And then I'm going to do this at the same time. Add 5 over 2x to this side. And add 7 to this side. So when we're adding fractions, and of course you put this in your calculator, these have the same denominator. So this is the same thing. I have 1 plus 5 over 2. For this one, you should have gotten a whole number, so if you did and got this, then it was it. Okay, so don't let the fraction freak you out. When you distribute that 3 to the 5, 6, think about that 3 as it has a whole number. It is a whole number. It has a 1 underneath. So we could think about it as a fraction, and when we multiply fractions together, we're just multiplying straight across. So 3 times 5, 1 times 6, and then I simplified it to get 5 over 2. You could have also left it as 15 over 6 at the beginning. And did the rest of that math, you would have got the same answer either way. Do we have any questions on that one? Yes, exactly. Yeah. Number 4 was a little tricky if you didn't know not, I guess, how to solve it, but how it would make infinitely many solutions. So it asks for what value of k will the equation have infinitely many solutions, and this was the original equation. So what it wanted us to do was find some number we could put in for k that would make these equal and would make this solution an infinitely many solution at the end. Anyone come up with a value for k? Looking at it, it may be a little difficult to see, but what I started doing was I went ahead and I distributed this side to see what this would look like. So I see that this is negative 8x minus 2. I have the negative 2s, those are the same. Remember, for infinitely many solutions, both sides have to be identical. Somehow I have to get 1/2 k equal negative 8. So in my mind, it's an algebraic mind. So I'm thinking, okay, what could I multiply to 1/2 to give me negative 8? Or I could have actually solved this. So if k is negative 16, and I put negative 16 in, then negative 16 times 1/2, or negative 16 divided by 2 is negative 8. And now this. So you may have not saw it like that because you have all these different variables. What are they all supposed to be? But if you look at just a smaller piece of it, it makes it a little easier.
So then you get to multiply by 2.
So if I'm trying to get rid of just 1/2, because the opposite of multiplication is division. So technically, I'm dividing both sides of 1/2. But in math, we don't like dividing by fractions when it's already in a fraction. When you divide by a fraction, what's really happening is negative 8 over 1/2 in your calculator. What they're really doing is taking the reciprocal and multiplying by that. Does that make more sense? That was just to get your mind working some more on solving equations. You should have in front of you the next and last set of notes for this unit that we're doing. And that is solving literal equations. So this first page is really just a bunch of words to kind of get you in the mindset of what this means. So if I said the difference between is raining cats and dogs and is literally raining cats and dogs, what would the difference be?
It's literally.
Like, what would that mean? Like actually happening. But like, and these are just some other examples. People don't actually take out one spine when saying "I got your back." But a literal equation, we are solving it for whatever variable it's asked for. Like you would a normal because you're not going to get an actual answer. So it's a little different. This picture just kind of shows if I solve this for x, any of these numbers could be, I don't know, I'm not actually solving it for a numerical answer, I'm solving it for this would be my x equation if I ever had what y was or something like that. So, a lot of these are similar to when we're solving regular equations. They're just there if you need them. But we're going to do a few of these together. So some of these are regular equations that we would solve and get a number. And then there are some that are not. So we're kind of going to do both so you see how to do the ones that are not. So if I have this example, solve 2x equals 10 for x. How would I get x by itself?
Divide by 2 on both sides.
Divide by 2 on both sides. And I get some number. I can put that back in. 2 times 5 equals 10. That works. So now for example 2, I no longer have numbers. I'm still solving for a variable, and the process is going to work the same way. So if I'm trying to solve this for h, how would I get h by itself? Divide both sides by g. I have some h equals m over g. I have no idea what h is, or m is, or g is. But this would be the equation for h if I knew those variables, or knew the value of those variables. You can still check literal equations. It just gets a little complex because they're letters and you don't have numbers. The same way you would any other, this is not a Desmos contact. You just have to be careful. So where h is in the original problem, basically, when you're checking this, if you put it back in, once you solve everything, if you get a variable equals the same variable, then it works. Kind of like our true statement. So here, the g's will cancel, leaving just m equals m. Questions on how we did that one or why that works? Example 3 is another regular equation that has numbers. We're going to solve for x. How would I solve this for x? Have 5 on both sides. And then divide both sides by 2. I get a number. I can put that back in. 3 times 2 is 6. 6 plus 5 is 11. Same thing for example 4, except all of them are now variables. So if I'm trying to solve this for x, what would I do? Subtract these from both sides. And in this case, I can't combine these. They're not like terms. So when I subtract, it just goes to the other side. And then when I divide both sides by a, again, I cannot simplify this because I don't know these values, except for this part. I know these are going to cancel. Then I'm just left with c times b over a. I don't know what any of those are, but this would be the equation for x. I'm going to again go back and put the check in. And again, this gets more complex the more you're solving for stuff. So where x is in the original equation, I'm going to put c minus b over a. If at the end I get C equals C, then this works. When I put in this equation, these cancel. Leaving me with C minus B plus this B. These cancel. Leaving this C and this. Any questions about that one? For 5 and 6, there are numbers there, but we have two different variables, so we're not going to end up with a number. We're just going to do one of these. Let's say, for example, 5. If I had 3x minus 6y equals 17, I'm trying to get x by itself. What do I do first? So I'm going to take this entire term and move it over, not just y or not just 6, but this entire term. (17) and 6y are not like terms. I can't combine them, so it's just going to go over there and stay. And then, how would I get x by itself? So with this, you can write this a couple different ways. As that whole fraction, leave it alone. There are some parts of this that you could simplify. So if you wanted to do that, you would need to separate this into two fractions, meaning have 17 over 3 and 6y over 3. If you separate it like that, then you could simplify this 6y over 3 to 2y. And if you wanted to rearrange that so it's 2y plus 17 over 3, you could do that as well. I am going to show you the check, but this one gets a little messy. The check would work for really this one, all of the different variations, but I'm just going to show this one. So that would be the easiest. And this box, we don't have space. If I put this back in to check it, these 3's are going to cancel. The 6y's then cancel. And I'm left with 17 equals 7. Which I know is a true statement. So even though they are not numbers, it would still help if you checked yourself to see, do you still get that true statement? That way you know you did this. 7 and 8 are very much like 5 and 6, except they don't have numbers at all. It's all variable. So we'll do one of those and have them choose practice for the rest of the class. AB plus CB equals G. We're solving for A. What would be the first step? ones. I cannot combine them. So this is a little bit. And then I go side by side. And that would be our equation for A. Putting that back in to check it really fast. These B's cancel, leaving just G minus C plus C. These cancel, leaving just G. Any questions on solving literal equations? For the remainder of class, you have different options. There is a page of extra practice, and then it says homework practice. It's not actually homework. You can work through any of those. And if you feel like you have a good handle on this and would rather jump to the other assignments, there is a Delta Math on literal equations that's due on Thursday. There's also 2 Khan Academies that's not on literal equations, it's just on the solving multi-step, that is also due on Thursday. Remember, the Khan Academy goes into the gradebook. Whatever you get on Khan Academy is what I put in. You can redo those as many times as you need to or want to get the grade you want to go into the gradebook. Right, so you can work on any of those. I do want to mention that I don't know if you guys saw this or not. Your course calendar, I changed some of the dates for your quizzes and tests because I wanted to have enough time for you guys to take the quiz, for us to go over the quiz, and then you guys take the test. So Thursday, you guys are going to take the 1.1, so that's solving multi-step equations. I'll explain how exactly we're going to do that on that day, but just keep that in mind for Thursday. If you miss the quiz, the test is going to replace it, so there won't be a makeup for that. The test will just replace it, so just keep that in mind. As you're working, if you have any questions, raise your hand. I'll be